All right, functions, this was part of the warm-up that we did today. So go ahead and hit pause and do this warm-up. It will help you. It's got those exponent rules, and I just kind of want to go over it. Okay, go ahead and hit pause. Okay, so remember when you multiply a base by a base, you add the exponents. So the first thing that we're going to do, if I can get it, yep, we're going to add those exponents. So m to the x plus 6, which is m to the 14th. M to the 5th times p to the 4th, no, those bases don't match. So we can't actually simplify those any further because the m and the p are not the same. So the product rule does not apply. And now we are going to take care of this one. So we have negative 5p to the 4th, negative 9p to the 5th. So we're going to multiply those coefficients. We have the two p's next to each other, so we're going to add those exponents. And we end up with 45p to the 9th. And then we're going to do the exact same thing with d. So we're going to multiply those coefficients, multiply the x's, multiply the y's. We add those exponents, and we end up with negative 21, x to the 3rd, y to the 7th. Again, if you have any questions, please ask. All right, so 29 to the 0 power is going to be 1. Anything to the 0 power is 1. Now this negative 29 right here, this is saying that this 0 power goes to everything inside the parentheses, so we are going to have 1. Now remember, this 0 is only going to go to what it's touching. So it's going to be negative 1 times 29 to the 0 power, which is negative 1. And then we have 8 to the 0 power minus 15 to the 0 power, which is 1 minus 1, which is 0. All right, so now we're going to use the rules of exponents to help us with rational exponents. Okay, so our first example is going to be, oh yeah, I want to go over the rules. So the rules for our rational exponents are actually, we already have these in our notes. These are the exact same rules we're going to use with whole numbers. So when you do a base times a base, you add the exponents. Remember, when you have a negative exponent, you're going to move it down to the denominator. If it's in the numerator, if it's down here, you move it up here. So you subtract the bases, or subtract the exponents when you are dividing, and then you multiply the exponents when you take a power to a power, and then make sure that exponent goes to everything inside those parentheses, and then it's just restated. You can look at your notes again. We've already done this, so we're going to practice. So we have 3 halves, 3 to the 1/2 times 3 to the 1/3, which is adding those exponents. Now, these are fractions, so we are going to have 1 over 2. Okay, this thing is not working. Hold on. My pen's not really working, so you'll have to bear with me. So if we have 1 over 2 plus 1 over 3, we have to get a common denominator. So I'm going to multiply top and bottom by 3 over 3, top and bottom by 2 over 2 on this side, and that'll give us 3 to the 3/6 plus 2/6, right? Because we keep that base the same. Now the question I got a lot was, why don't we multiply the 3's? And that's because it's not 3 times 3. So my pen's just not going to work. I don't know what's going on. It's not 3 times 3. So if we did x times x, we would end up with x squared, right? So the base stays the same, and we deal with the exponents. So that's why we don't worry about multiplying the 3 times the 3. Plus, it's really 3 to the 1/2. So this is saying the square root of 3 times the cubed root of 3, which is not 3. So when we do that, then we add those exponents, and when we're adding we're adding fractions, we do top plus top, and the bottom stays the same, so we end up with 3 to the 5/6. The same is true when we're doing division. So we're actually going to subtract these exponents. So we're going to do 7 to the 2/3 minus 4/3. And that is going to get us 2 minus 4 is negative 2. And now I've got this negative exponent right here. And because I have this negative exponent, I know I need to move it to the denominator. And then we end up with 1 over 7 to the 2/3. Okay, so what we're going to do with this one is we're going to deal with everything that's in the parentheses. So a to the 1/3 doesn't simplify anything, so there's no other a's. But we are going to have b to the 2/3, and remember the exponent here is 1. It's not going to let me write it. I'm trying. 1. So we're going to have 2/3 minus 1. So there's the A. It didn't change. There's the B. 2/3 minus 1. And we need to make this a common denominator, so that's going to be 3/3. So then we really have 2 minus 3/3. So we end up with x to the 1/3, b to the 1/3, and now we can take care of this exponent, right? So this means that I'm going to multiply, I'm going to take a to the 1/3 to the 6th power and b to the negative 1/3 to the 6th power. And then when we take a power to a power, we multiply them. And since we're going to multiply them, we end up with a to the 6/3 and b to the negative 6/3, which will give us a squared when we simplify those fractions, and b to the negative 2nd. Now I do have this negative exponent, and I cannot have any negative exponents. So I'm going to go ahead and move that down to the denominator. The a squared stays in the numerator because it was positive, and it goes over b squared. Okay, now we're going to do this. So this C was a good example of a meeting level question, but this is also a good meeting level question. So again, I'm going to deal with the stuff inside the parentheses first. So I'm going to do a to the 3rd minus negative 2, b to the negative 4th minus 1/5. So a to the negative 3 minus negative 2, b to the negative 4 minus 1/5. Now that negative 4 and 1/5, I need to get a common denominator. And so when I get that common denominator, I'm going to end up with, it looks like I'm going to end up with negative 20/5 minus 1/5, which gives me negative 21/5. And 3 minus negative 2 ends up a to the 5th. Now I'm going to take everything to the negative 1/2 power. So a to the 5th to the negative 1/2 and b to the negative 21/5 to the negative 1/2. And when I do that, I end up with a to the negative 5/2 and b to the negative 21/10. I simplify my answers, which I can't, and so I need to make my negative exponent positive, and I'm going to move that a down to the denominator. Okay, so this one, you actually do know how to do this. Most students kind of freak out when they see it, but if I gave you, I don't know why my pen is acting up. Hold on. Let me see if I can. Yeah, my pen's just not going to work, so I'll have to figure this out next week. Okay, so we're going to do this. I'm going to distribute this. So I'm going to do this times this plus this times this. We're just going to distribute it. So it's going to look like A. Hi, sorry, sorry, the janitor walked in and or the custodian walked in, and I think I scared him because I'm sitting in the dark because my lights turned off. Okay, so we're going to do r to the 2/5 times r to the 3/5 plus r to the 2/5 plus r to the 8/5, which gives us, now it's working, r to the 2/5 plus 3/5 plus r to the 2/5 plus 8/5. Then we end up with r to 5/5 because 2 plus 3 is 5, and r to the 10/5. We need to simplify those, and we end up with r plus r squared. Now remember, when you're adding and subtracting fractions, you cannot just put those together. They have to be exactly alike. Now if we were multiplying, that would be different, but we're not. So when you add and subtract, you can only combine like terms. Okay, so now we're going to go from radical form, we're going to convert it to exponential form. Something that you need to make note, it says leave your answers in exponential forms. So when we do that, we need to make sure we read those directions. So on the test last year, students wouldn't do that. It would say leave your answer in radical form, and they wouldn't do it. They would convert it and then forget to convert it back. So this one is saying to leave it in exponential form. So when we get our answer and we have it in exponential form, we're just going to leave it. So the first thing we want to do is we want to convert these to exponential form. So we're going to get x to the 3/4 times x to the 1/5. And now it's just like the past slide. Now we just add those fractions together, and we get 3/4 plus 1/5. We got to get common denominators, and we end up with 15/20 plus 4/20, and 15 plus 4 is 19, and we get x to the 19/20. We're done. We are leaving it in exponential form. It's fully simplified. That fraction doesn't go down anymore. We're done. Okay, let's try this with division. So again, we're going to convert to exponential form. So we end up with x to the 5/2 over x to the 1/3. When we have division like that, we do subtraction. So we're going to get x to the 5/2 minus 1/3, which when we get our common denominator, gives us x to the 15 over 6 minus 2 over 6. And 15 minus 2 is 13. And x to the 13 over 6, done. Can't simplify it. That fraction is fully simplified. We're done. Okay, and then this one you want to work your way inside, then out. So the first thing I'm going to do is I'm going to find the cubed root, and I'm going to write this particular one underneath in exponential form. So then I have x to the 1/6 right here. So I have the cube root of that. So then I know that everything needs to go in parentheses, and then I'm going to take this to the 1/3. So that means now I'm multiplying, right? Because I have a power to a power. So then I'm going to end up with 1/6 times 1/3, and fractions top times top equals top, and bottom times bottom equals bottom. So we end up with 18 to the 1 over 18. I'm sorry, x to the 1 over 18. If you have any questions, please come to class with those. I will have a worksheet for you to work on Monday for you to practice. Otherwise, I hope you have a great weekend, and good luck tonight with the basketball game. Go Hawks!